Hello again, guys. How are you? Again, we hope you are doing well. So, still, we are in chapter 20, electromagnetic induction, section 3, transformers. Last lecture, we said that transformer is a device that increase or decrease the electromotive force, the voltage of the alternating current. And we said we have a relationship between the voltage and the number of the turns. Again, we said we have primary coil, which is all the time number 1, and we have secondary coil, which is all the time number 2. Today, I have some videos, so it will help you to make everything clear.
Transformers are devices that increase or decrease the electromotive force, or EMF, of alternating current. Their power plants generate alternating current with an EMF of tens of thousands of volts, much higher than would be practical for everyday applications. When current travels through transmission lines, some power is lost as heat due to the resistance in the wires. The greater the current, the greater the percentage loss of power. So, to minimize power loss, power companies want to transmit electricity with a low current and a high EMF.
So actually the current which comes from the power stations or power generation plant, it's most of the time about like 200,000 voltage sometimes. Sometimes it's 150,000 voltage, and that's to minimize the energy which lost inside the transmission line. Because of that, we need to use transformers. First one, it's a step up, so we can increase the electromotive force.
Transformers at a substation near the generation plant increase the EMF to hundreds of thousands of volts before sending the current through transmission lines to industries and neighborhoods. As the current gets closer to the end users, it passes through distribution substations that step down the EMF to several thousand volts. The canisters you see on utility poles are transformers stepping the EMF down to 120 volts before the current is sent into homes and businesses. Inside a home, some electrical appliances, such as lights, fans, and televisions, run on 120-volt current. Many electronic devices, such as computers, mobile phones, and MP3 players, are designed to run on much less than 120 volts. Inside the bulky adapters plugged into these devices are transformers that reduce the EMF to the level needed. Many adapters also convert the current from alternating to direct. Click the Feature tab to explore the Using what you've learned about how a The EMF across the secondary coil of a transformer can be predicted using the formula shown here. Delta V2 represents the EMF across the secondary, delta V1 represents the EMF across the primary, and N2 and N1 represent the number of turns in the secondary and primary coils, respectively. Click in a step-down transformer, the secondary coil has fewer turns than the primary. This causes the EMF across the secondary to be smaller than the EMF across the primary.
So here we have a step-down transformer. As you can see, the number of the turns in the secondary coil much less than the number of the turns in the primary coil. So, since here we have N2 less than N1, N2 is the number of the turns in the secondary coil, and N1 is the number of the turns in the primary coil. So, since N2 less than N1, that's mean voltage or EMF or delta V in the secondary less than the voltage at the primary. That means step down. because all the time the input from the primary. So here we have the input and here we have the output. So here the output will be much less than the input. Actually, it's going to be the half, because here the number of the turns in the secondary coil is the half of the number of the turns at the primary coil. So if here we have, for example, 200 voltage, here we're going to have only 100 volt. So it's a step down transformer.
In a step-up transformer, the secondary coil has more turns than the primary. As a result, the secondary EMF is larger than the primary EMF.
So here the number of the turns at the secondary much more than the number of the turns at the primary coil. So here the voltage, the output voltage, it's going to be more and higher than the input voltage. For example, here if we have 100 volt only as input, so the output will be 200. So we said before delta V2 is equal to N2 divided by N1 multiplied by delta V1, or we can say delta V1 over delta V2 over delta V1, it's equal to N2 over N1, the same. And we said it's possible to have 100% efficiency for any real transformer, because some energy will lose inside the coil, inside the core, and surrounding the coil as a heat and as an electromagnetic wave. So it's enough for today, guys. Good luck. See you next session, inshallah.